All right, here we're going to look through our notes for section 1.5, and we always want to start with our learning targets. So today we're really going to look at these last three and kind of wrap up our unit. So the first one is rewrite literal equations. First we have to figure out what a literal equation is, and then we're going to rewrite them. Then the last two are we're going to rewrite and use formulas for area, and then some other common formulas. And I have these common formulas for you. So just keep paying attention and make sure you get these written down because you're going to use them quite a bit. So our last page of our notes that we were dealing with and we were looking at was our absolute value equations. So on the next page, this is where we're really going to be looking at literal equations and formulas. So what you really need is this sheet right here that I've handed you. This is where we're going to kind of capture most of our notes that we're taking today. So the first thing is we want to kind of define what a literal equation is. So a literal equation is an equation, and remember what equation means, it has an equal sign, but this equation contains two or more variables. So we've been looking at a lot of some of these equations, so like y equals 2x plus 4, that's a literal equation because I've got at least two variables. We're going to look at some specifics here pretty soon. So then what is a formula? A formula is an equation. So again, we're dealing with equations that states a rule. So these are things that are kind of always true that are about a relationship. Okay, so formulas are just a certain type of literal equation. Okay, so now let's look at some examples of literal equation. Okay, so this top part is really going to be where we're starting. So the steps we have to do, when we have a literal equation, here's the example that we're going to be looking at, and we'll follow these steps to get there. So our example is to solve y equals 3x plus 5xz for x. So I have this equation, it's got a bunch of different variables in it, it's already solved for y, but I'm being asked to solve it for x. So the first step we have to do is we have to locate the variable that we're being asked to solve. So for example, for this example, it's x. And I have more than one of them. And that's okay. And that's why I picked this example so we can kind of go for there. So the next thing we have to ask ourselves is what operations are being done to this variable? What's happening? So then, just like we've been doing when we solve for just one variable, here we have to use our inverse operations again to undo what's being done to it and to solve and to isolate the variable. Okay, so let's walk through this example. So I see I have y equals 3x plus 5xz. So the first thing I have to do is make sure that the only thing on the one side of the equation has that variable in it. So everything on the right side of this equation has to have an x in it, since that's what I'm solving for. Everything else needs to go to the left side. So every term here I see has an x with it. So we're good there. So everything's already moved over. So I notice that this x is in more than one place. So how I can undo that is when we were solving equations, we would always start with the distributive property. Well, now we kind of want to undo that. So if I was to take this x out, I still have y equals, but now if I undo that, I undo my distributive property, I end up with x times 3 plus 5z. Okay, so all I've done is I've taken that x out. And I'm going to keep my x highlighted so I can keep track of it pretty easily. So now the next thing I need to undo, right, would be to kind of follow my same order. So if there was any addition or subtraction, I would undo that. But here I see I'm multiplying. So to undo this multiplication, I would divide by my 3 plus 5z. We want to think about this as one big entity and not deal with each individual number. Well, what I do to one side, I have to do to the other side. So I end up with x equals y divided by 3 plus 5z. So now I've actually solved this equation for x because x is the only thing over here. So we've done. So we did great on that one. So remember, anytime you're solving for something, that just means get it all by itself. So now let's look at some formulas that you're going to need. So what you're going to do in here are, I'm going to give you some of these other formulas that we're going to deal with. And then on the bottom page of your notes, right after we glue this, you are going to go through and find some of the other formulas for area. So you're going to need to find the formula for the area of a square and a rectangle and a circle and a triangle. Those are really kind of where we're going to live. And go ahead and write those in your notes. But let's look at these other formulas. So we're going to look at the temperature formula. So here we have F, and it's a capital F, and it does matter, equals degrees Fahrenheit, and C equals degrees Celsius. So the formula that we use for Fahrenheit and Celsius is C equals 5/9 times the quantity, and that means we're to have a parentheses, F minus 32. So you'll see here that C is the one that's all by itself. In your examples and in your homework, you are going to be asked to solve for F. So can you follow these steps above that we just did for the literal equations and solve for F here? That's why we're really looking at these different formulas. So we can go back and forth between the 2 or 3 or 4 quantities. The next formula we're really looking at is simple interest, where a capital I is our interest, P equals the principal. Now principal is like the starting amount. A little r is the rate, the interest rate, and this has to be in a decimal form. So you're going to most often be given a percentage here, so you have to first turn it to a decimal, and then T is time. And this time is in years. Okay, so our equation or our formula for this is I equals PRT. And again, you are going to be solving for different variables here, so based on the problem that you're given. The other formula we're looking at, D equals distance, R equals rate, and T equals time. This is the distance and rate formula, so it's D equals RT. So now that we have these common formulas, now when you're working on these equations and these examples, you can rewrite them and get them to be exactly how you need them to be. For example, you're going to be given some problems with temperature. And you're going to be told, okay, so our temperature is 4 degrees Celsius. What is it in Fahrenheit? Well, using this equation as it's written is not the most useful way to do that. It would be much more useful to actually solve for F first by following these steps up here, solving this literal equation for F, and then you can plug in the values that you have. So that's why we want to do this, so we can go back and forth between these. So now you're going to go ahead and glue or tape this in your notebook for this page, right? And just like I said, down below here is where you're going to find those equations for area. If you remember them like the back of your hand, awesome. You don't need to write them down. But many of us struggle with remembering our different area formulas, so that's where you're going to go ahead and just put them down because you're going to use them a bunch in this unit. So don't forget rectangle, square, circle, triangle. Those are kind of your big main ones that we're going to be using. So now you should be ready to go through and work on your practice problems for this section. And as always, ask and come find me whenever you have questions.